section on algebra-based review. It is 8-0 because it's not really in this book. It's a review of a concept that you've had before. Actually, my other class seemed to grab a hold of this and do very well. We'll see how it goes for y'all. Let me know if you have any trouble, if you have any questions, anything about it. And let's go ahead and get started. First things first, guys. There is something called simplifying radicals. It's called simplest radical form when you hear about the form that it goes in. And that's going to require you to use numbers like this and take them and take the square root of them, but do it in what we call simplest radical form. To do that, you're going to break it down into what we call a nice number and a not nice number. So when you look at this square root of 20, you're going to take and break this down into a nice number at the front and a not nice number at the back. So guess what? Here's your list of the first nice numbers. So out of these nice numbers, and you're going to hear me use that term a lot, they're called perfect squares. We'll get more into that in a second. But out of these nice numbers, which one of these numbers will divide into 20? 4. Perfect. So 4 goes into here. To find the other number, all you do is 20 divided by 4. That should give you 5. Okay. Once you do that, you're going to take the square root of 4 and the square root of 5. Guys, grab your calculators. Let's talk about this. Grab them. It's about the calculator work. What is the square root of 4? 2. Cross it out. Put the 2 above it. Now do the square root of 5. It doesn't ever end. It's a nasty decimal. That's why it's called not a nice number. In simplest radical form, we don't actually take the square root of that number. We leave it as the square root of 5. It's called radical 5, square root of 5, either way you want to say it. And it is written like this: 2 square roots of 5, or 2 radical 5. And that is how you would leave your answer. You have broken down the nice number. You have left the ugly number under the radical like it is. It's called ugly because when you try to take the square root of it, it gives you this decimal that never ends. This is also called an exact answer. That's really important that you hear that and that you write that down, because exact answers are something they're going to ask for on test and on the EOC. When they say exact, that means you cannot round your answers. They want you to leave it in simplest radical form. Right? Exact answers. Now guys, the nice numbers are ones that have perfect squares. Here's the list of the first ones. Okay? 4, 9, 16, 20, all these. Because watch. What's the square root of 4? 2. What's the square root of 9? You should see a pattern here. What's the square root of 16? 4 times 4 gives you 16. And then the square root of 25 would be 5, because 5 times 5 is 25, and etc., etc. It goes 6, 7, 8, 9, 10, 11, and 12. Now, I will tell you that there are several that are common that you need to know that are above that. You'll need to know this list, guys. It's really easy to create because you can just say 2 times 2 is 4. 3 times 3 is 9. So if you don't memorize it, guess what? You can always make it. It's really easy. It just takes a little time. Okay, there are some other common ones you need to know because I know the test, the worksheet today uses this. Square root of 169 is going to be what? You've got a calculator, use it. 13. Square root of 225 is what? 15. There we go. What's another common one? Square root of 400? 20. And we'll do one more because it always ends up being in there. 625. There you go. Those are the most common perfect squares. Now notice, what number is not at the list at the very beginning? Square root of what? 1. Is 1 a perfect square? Yes, but guys, think about this. If I broke this 5 down, if I kept going and broke it down, or here, you don't even do it at the beginning. Let's say I had a number like this, so just so we don't mix it up with this. Let's say I had a number that's like the square root of 7, because 7's prime. It doesn't divide by anything except for 1 and 7. Let's say I broke it down into the square root of 1 and the square root of 7. My nice number always goes first, guys. You do need to know that. Meg, come see me for a second. It doesn't take that long. does. Listen, no, it's become every time though. So I'm not letting you go and just do all that for that long. So if there's something that you need to deal with, you need to write a pass, you need to deal with it. If you ask to use the restroom before the bell, then you need to be back here quickly. Okay, thank you. Okay, guys, the reason this doesn't matter is because the square root of 1 is 1. And 1 times the square root of 7 is, guess what? The square root of 7. And we're right back where we started. Does it help to break it down with 1? No, it does nothing. So the whole idea is you're going to start with that 4 as the first one that we would break it into for the nice numbers. You're going to break it into a nice number at the front, a not nice number, an ugly number at the back, and then you're going to simplify it. Okay, so let's show you some problems. Here we go. Okay, square root of 12. Should be fairly obvious. Let's see if we can get the two numbers. Again, if you think of it like factor trees, remember y'all did this where you took a number and you factored it and broke it down? Okay, it's the same idea, but one of the numbers has to be nice, one of them is going to be the ugly. So what nice number goes into 12? 4. What's the other number? 3. And what's the square root of 4? 2. So it's going to be 2 square roots of 3. 2 square roots of 3. Good. For the next one, guys, most people see this right away, but you can always take your calculator and just start dividing, guys. What are you dividing by? You're dividing by 4. You're dividing by 9. You're dividing by 16. You're dividing by 25. What goes into 90? 9 and 10. Perfect. And what is the square root of 9? Guys, notice I cross it out. I put the 3 on the outside because it no longer has a radical sign. Once you take the square root of something, it no longer has a radical sign on it. That's why I write it like this, so I don't keep that radical sign on it. I cross it out, I put the 3 up top, and I write it as 3 square roots of 10. You'll also see later why putting it up top helps you, because you're going to have to multiply in a little bit. Guys, there's a reason I write things the way that I do. Alright, anybody else? Okay, let's keep breaking them down. Okay, square root of 52. 4 and 13, thank you. So we've got 4 as our nice number, 13 is our ugly number. 13 is really ugly, it's prime, doesn't break down at all. Square root of 4 is going to be 2. So we'd write it 2 radical 13, 2 square roots of 13, however you want to say that. As long as you say it with that radical in some way, shape, or form, those are both correct. Now, 72, don't say anything yet. Break it down into a nice and not nice number. I want everybody to have it broken down before we say it, because I want to talk about why this is such an issue. Alright, somebody tell me, what did they break down the 72 into? 9 and 8. Did anybody have different numbers? Because there are different numbers, yes. 36 and 2. Anybody have any other numbers? Oh, really? It could also be 4 and 18. These all work, guys. That's the problem with this, is that it can go different ways. The nice thing is that's good because all of y'all saw it differently. Okay? But you've got to start and get it broke down. Let's show you this one. The 9 and 8 is the most common, so I'll start with this one. So the square root of 9 is 3. I put it on the outside, I put it out in front, 3 square roots of 8. Why is that not my answer? That's not the answer. Tell me why it would not be my answer. Ooh, what can 8? The 8 can break down still. Guys, if you still have a perfect square that can go into that number, you are not done. What perfect square goes into 8? Nicely done. 4, and the other number would be 2. Right? This is why I told you to write it this way. Watch carefully. Look. The square root of 4 is 2. These numbers are next to each other. They're going to have to be multiplied. So 3 times 2 is going to give us 6 square roots of 2. Now, the bigger number you put into it first, I think it was Dariah, is that yours? Did you say that? Okay. That's going to be quick, because what's the square root of 6, guys? I mean, it's 36. Y'all are not nice. Don't laugh at me. So that's going to be 6. So it's going to be, I laughed at myself, 6 square roots of 2. Sorry, I answered your question for you. See how my brain thinks in front of my, it messes me up sometimes. I think in front of what I say. So it's going to be 6 square roots of 2. And you only have one step. Now 4 and 18, again, it's not bad. It's just that you got to do it more than once. That'd make it 2 square roots of 18. And then the square root of 18, would break down into the square root of what two numbers? 9 and 2. And the square root of 9 would be 3. But 2 times 3 is going to be 6 square roots of 2. Did y'all see that we just did it 3 separate ways, but we got the exact same answer every time? Even though I told you how to do it. Okay, guys, let's try another one. 34. Okay, start dividing. 34 divided by 4. 34 divided by 9. 34 divided by 16. 34 divided by 25. Now guys, do you see the numbers past that are bigger than 34? Do I have to divide by those? No, it's not going to matter. So guys, does it divide by any of them?
No.
So that means that this is already in simplest radical form. It cannot break down at all. So the answer is, bless you, the answer actually is the square root of 34. Okay. If you can't break down, just put that answer. That is your answer. That's simplest radical form of that number. Oh, the next one's unique too. Guys, the square root of 36 should not have to break down into anything because the square root of 36 is a what? Perfect square. It's a nice number. Because of that, the square root of 36 is 6. Just 6. No radical, no nothing. It's just 6. Same thing if you had, let's see. Sorry, my calculator's off. Hold on. What if you had one like this? I'm just adding this in as another, like, because you're going to have some bigger numbers on your assignment. What if you had one like that? When you go to try to break that down, the first thing you ought to do with a big number like that is type it on your calculator and hit the square root button. Because the square root of 2500 is 50, and you don't have any work to do. Now, if it won't break down first, then you got to go to nice and not nice and do all that. But some of them are just perfect squares. Okay? Big numbers, small numbers, doesn't matter. They're still perfect squares. Okay, guys. Anything before I keep going? Here we go. 2 times 40 square, 2 times square root of 45. Is this the first one that's been like this, where it had a number in front? Yeah. Okay, so we're going to keep the 2 in front. We're going to break down the 45 into nice and not nice. What goes into 45 from that list? 9. That means 9 would be 5 for the other number. Perfect. The square root of 9 is 3. And then just like the one where we had already simplified it once, we multiply these two, and it'd be 6 square roots of 5. Perfect. 6 square roots of 5. Is this our last one? Yeah. Okay, here we go. Last one for today. 5 square roots of, and then we're going to break down the 147. Now, personally, took me, actually, guys, most of them I can look at them and tell what number is going to go into it. This one, it took me a second. I had to actually grab my calculator and divide. Y'all may see it immediately. I did not see it immediately. Does anybody know what it is yet? 49 and 3. Took me taking my calculator and kind of think, I just don't think about the multiples of 49. It's just not, like, wasn't going there. So, square root of 49 is what? 7. So 5 times 7 is going to put us at 35. And then the radical 3. Square root of 3, however you want to say it. Good job, guys. So, this is what we're going to be doing today. We have a lot of time. So, guys, you should be finishing this. It's not getting close. You should be getting this done in class today. Okay?